Hi students, this is Ms. Tai here. In this video, we will review the June 2024 Algebra 1 Regents. This is the first version of the new Algebra 1 Regents that's incorporating the new reference sheet and a few changes to the exam. Grab a notebook and pencil and let's get started. Question number 1. A ball was launched into the air and its height above the ground was recorded each second as shown in the table below. Based on these data, which statement is a valid conclusion? This is a projectile motion problem. We start off at 0 seconds and a height of 11. So if we just do a quick sketch right here, at 0 seconds, the height of the ball was at 11. At 1 second, it jumps up to 59. At 2 seconds, it goes up to 75. At 3 seconds, it's back down to 59. And at 4 seconds, it's back down to 11. So we can see that this graph is taking the shape of an upside down parabola. Let's take a look at the answer choices. The ball lands on the ground at 4 seconds. That is not true. If the ball was on the ground at 4 seconds, we would have a time of 4, which would be our input value, and we would have a height of 0. So the 0.4 comma 0 would be in our table, and the graph would be on the x-axis when x is 4 seconds. And that's not the case. So this is incorrect. The ball reaches a maximum height of 11 feet. This is incorrect because the maximum height according to our graph is 75 feet. That's happening right here at the vertex. So that is also incorrect. The ball was launched from a height of 0 feet. At 0 seconds, the ball was actually launched from a height of 11 feet. So that is also incorrect. Answer choice 4 says the ball reaches its maximum height at 2 seconds. And that is correct. When x equals 2 seconds, the y-coordinate is 75 feet. And that is going to be the maximum height of the ball. So answer choice 4 is correct. Let's continue. Number 2, a tour bus can seat at most 48 passengers. An adult ticket costs $18 and a child ticket costs $12. The bus company must collect at least $650 to make a profit. If A represents the number of adult tickets sold and C represents the number of child tickets sold, which system of inequalities models this situation if they make a profit? Let's take a look at our numbers. It says a tour bus can seat at most 48 passengers. So the term here, at most, is going to reference less than or equal to 48 passengers. So we can have 48 passengers, 47, 46, 45, 44, but the whole point here is we're going to include 48. So we're looking for an answer choice that has less than or equal to 48. Notice answer choice 1 and 3 simply has less than, but answer choice 2 and 4 has less than or equal to. So we can eliminate choice 1 and choice 3. We can also confirm that it says that the bus company needs to collect at least $650. So that is going to be greater than or equal to $650. So we can tell that answer choice 2 is the correct answer just by looking at the inequality symbols, because we want to ensure that the amount of money that they're bringing in is greater than or equal to $650. Notice in answer choice 4, they use the less than or equal to symbol. So that is actually incorrect. Of course, A plus C, which is the number of actual tickets, must be less than or equal to 48. And then $18 times A and $12 times C must be greater than or equal to $650. So all we needed to do is understand what at most and at least means to ensure that the correct inequality symbols were used. Answer choice 2 is the correct answer. Let's continue. Number 3, which equation is always true? Here's a quick tip. When multiplying exponents with the same base, you must always keep the base and add the exponents. Let's take a look. For number 1, we have x squared times x cubed equals x to the 5th power. Because the bases are the same, we will have x to the 2 plus 3, which equals x to the 5th power. So at a first glance, answer choice 1 is correct. But let's take a look at the other answer choices. 3 to the x times 3 squared should be 3 to the x plus 2. We're going to add x plus 2 because the bases are the same. Notice this is incorrect. They have 9 to the 2x, so that's not right. Negative z squared is not necessarily equal to z squared. For example, let's say we had negative 3 squared and 3 squared. One is going to be negative 9 and the other one is going to be 9. So it is not necessarily always true that negative z squared and z squared are equivalent. And for answer choice 4, we have 7 to the a times 7 to the b, which should be 7 to the a plus b, not 7 to the a times b. So that is also incorrect. So answer choice 1 is the correct answer. Let's continue. Number 4, the expression negative 2 times x squared minus 2x plus 1 plus 3x squared plus 3x minus 5 is equivalent to. Let's go ahead and perform the distributive property and then combine like terms. I will first start by writing out our problem. So I will distribute negative 2 to each of these terms. We now have negative 2x squared plus 4x minus 2. We technically have an imaginary 1 outside of the parentheses here. So we are going to distribute positive 1, but as we know, when you multiply any term by 1, you will get the exact same term. So we will have 3x squared plus 3x minus 5. Now let's go ahead and combine like terms. Negative 2x squared is a like term with positive 3x squared. 4x is a like term with positive 3x, and negative 2 is a like term with negative 5. When we go ahead and combine these like terms, we have positive x squared, right? Because 3 minus 2 is 1, so we have 1x squared, which is the same thing as x squared. 4x plus 3x is 7x, and negative 2 minus 5 is negative 7. We say when signs are the same, we add and keep the sign. So it is clear that the correct answer is choice 4. Let's continue. Number 5, which sum is irrational? Because I can see square roots here, we're going to use the definition of non-perfect square roots for an irrational number. There are typically 4 categories of irrational numbers that I use. It is anything involving pi, non-perfect square roots, non-perfect nth roots, and any non-repeating, non-terminating decimal. But for the purposes of this problem, since we're clearly working with square roots, we're looking for examples where they're going to be non-perfect square roots. So let's take a look. I can see in answer choice 1 that we have square root of 12, which is a non-perfect square root, and square root of 100. So this is a potential answer. For number 2, we have the square root of 4, which is a perfect square root, and the square root of 900, which is definitely also a perfect square root. So that's not going to be correct. For answer choice 3, we have square root of 25, which is perfect, and square root of 64, which is also perfect. So that's not going to be correct. Remember, we're looking for irrational numbers. For answer choice 4, we have square root of 49 and square root of 121, which are both perfect square roots. So again, answer choice 4 will also be incorrect. Let's take a deeper look into answer choice 1. Just by process of elimination, we kind of know that answer choice 1 is correct, but I still want you to see what is available to us in terms of simplifying the radicals. So we have negative 2 root 12 plus the square root of 100. By now, everyone here should know that the square root of 100 is 10. And for root 12, we're going to split it between the square root of 4 times the square root of 3. So we have negative 2 times the square root of 4 times the square root of 3, and then we're adding 10. So we have negative 2 times 2, and then we multiply that by the square root of 3. Notice once you evaluate the square root of 4 and you write down a 2, you no longer need the square root symbol. So now we have negative 4 root 3 plus 10. Notice these are not like terms, right? The only way we could add these two terms is if 10 also had a radical 3, and it doesn't. So we're going to leave it as is, and that means this final answer is left with a non-perfect square root. So that is why answer choice 1 is definitely going to be irrational. Another quick shortcut is to enter these answers into the calculator. And if you get a perfect number, whether it's an integer or a terminating decimal, that's going to be rational. And if you get a non-repeating, non-terminating decimal, it's going to be irrational. Let's continue. Number 6. The solution to 4 times x minus 5 divided by 3 plus 2 equals 14 is, we're going to go ahead and solve this equation. I'll first start off by writing out our equation. We will perform the inverse operation to solve for the unknown variable. We'll start off by subtracting 2 on both sides. So we have 4 times x minus 5 divided by 3 equals 12. Our next step is to perform the inverse operation of dividing by 3. The opposite of dividing by 3 is to multiply by 3. So the 3's will cancel out. We have 4 times x minus 5 equals 36. Our next step is to perform the distributive property. So we have 4 times x and 4 times negative 5. We're left with 4x minus 20 equals 36. Our next step is to add 20 to both sides. We have 4x equals 56. The final step is to divide by 4 on both sides. You can go ahead and enter this into the calculator or perform short division. 4 divided into 5 is 1, remainder 1, and 16 divided by 4 is 4. So x equals 14. Answer choice 2 is the correct answer. If your exam is right around the corner, another strategy is to just perform guess and check. You can enter 15 minus 5 into your calculator. You'll get 10. Multiply that by 4. You'll get 40. 40 divided by 3, and then add 2. And you'll notice it's not equal to 14. So you can go ahead and plug in each of these answer choices until you arrive at the correct answer, which in this case is answer choice 2. If you learned something in this video, please go ahead and like, comment, share, and subscribe, and I'll see you in the next video.